this lesson is Arithmetic Sequences Part 2. And so here in this lesson I will be going over two specific problems that I think are really invaluable in order for you to understand exactly what an arithmetic sequence is. So the first problem that I have here is the fourth term of an arithmetic sequence is 20. So let me just write that. The fourth term of an arithmetic sequence is 20. So this is given. And then we also know that the 13th term is 65. And we're supposed to find the first 5 terms of this sequence here. So that's the question. And we have these first two facts given to us, the fourth term and the 13th term. So now if we think about this, I know in the previous lesson I did go over this particular formula to find any nth term of an arithmetic sequence. And that formula states that an is equal to a1 plus n minus 1 times d, where d is the common difference. And so this is a formula that you want to use, right? And so that's the main formula to really determine any term, right? You can determine the nth term using that formula. So now we want to find the first 5 terms of this sequence. So the first step is really to plug in what you know, because you know an. So you know the fourth term. So you would say that a4 is equal to a1 plus, and you know here that n in this case would be 4. So you would do 4 minus 1 times d. So that's your equation. You could say equation number 1. And so if you solve this further, you see that a4, which you know is really 20. We are given that the fourth term is 20, so we can write 20 here, is equal to a1 plus 3d. So just simplified this, and we made this equation here into this, because it's just more simplified. And now, looking at the second equation, we can formulate another equation. Clearly here we know that a13 is equal to a1 plus 13 minus 1, which would be 12d. And we know that a13 is 65. Therefore 65 is equal to a1 plus 12d. So we have this equation here, that's equation 1, and we have equation 2, that's here, right? So we have our two equations here, and now really if we think about this, we want to do the system of equations. And if you look at this carefully, you know there's 3d here and there's 12d here. Well, if you multiply 3d by 4, you get 12d. So why not try to eliminate one of these variables, for instance d, to see what a1 is, right? So this is really a system of equations, right? And so if we multiply this entire expression by 4, we get 80 is equal to 4a1 plus 12d. Now we have this, and we already know that 65 is equal to a1 plus 12d, right? And so we can subtract this now. So when I mean subtract, you will see that when you do a1 minus 4a1, you get minus 3a1. 12d minus 12d is really nothing, and then you're doing 65 minus 80, which is negative 15. Therefore a1 is 5. So you know here the value of your first term using this formula, really. And so you know what a1 is. Now you know the value of a1 here, right? So when you're looking at your common difference, obviously if you know your value of your first term here, you can plug this back in. So you have 5 times 4, 20, 80 minus 20, 60, 60 divided by 12 is 5. Therefore your common difference, or d, is also 5 in this case. Now you know your d and your first term, and really now you can define that equation. So we say that an is equal to 5 plus n minus 1 times 5. This is our equation. We have to find the first 5 terms. And really, if we do this, we plug in 1 here for n to get the first term, right? a1 is the first term. So 1 minus 1 is 0 times 5 is 0, and add that to 5 is 5. Right? To find the second term, do the same thing. 2 minus 1 is 1 times 5 is 5 plus 5 is 10. And you see that this is an arithmetic sequence, therefore there must be a constant rate of change. So to determine, the question was find the first 5 terms of the sequence. You just add 5. So you have 5, 10, 15, 20, and then 25. So this is your final answer: 5, 10, 15, 20, and 25. Now this was a little bit more technical because we used this formula and we then used the system of equations. So it does give us a good understanding of this formula up here. However, you could think of this question in a different way as well. And so when I say in a different manner, what I'm really saying is that if you think about this, you know that an arithmetic sequence is defined as a sequence that has a constant rate of change. So if you know that the 4th term is 20, the 13th term is 65, you can do 65 minus 20, that's 45. And then you can do 13 minus 4, that's 9. 45 divided by 9 is 5. You already know your common difference here is 5. Right, you know and if you think about it, obviously you could have something like find the 100th term, and then this method may not be the best method, but you know that your common difference is 5. And so if you know your 4th term is 20, you know your 3rd term must be 15, 2nd term must be 10, and your 1st term must be 5. So these are our first 3 terms. To find the next 2 terms, it would be 20 and 25. And so that's just a shortcut. But again, that main idea is if you understand that there's a constant rate of change for an arithmetic sequence. So that was problem 1. Now, this is problem 2 here. So the problem 2 states that find the 10th term, right? Find the 10th term of an arithmetic sequence that begins with 8 and 20. So really something like that. So we're finding the 10th term for the sequence. And really, again, for this example here, we know what the first term is. So we're really going to say an is equal to a1, which in this case is 8, sorry. So a1 here is 8, and then we do 8 plus n minus 1 times by the common difference, and we know that because we know that the difference between 8 and 20 is 12. Right? So we know that, and now we can further simplify this. So we know an is equal to 8 plus 12n minus 12. Simplifying this further, we get an is equal to 12n minus 4. So that's the equation that we have. And now really we want to find the 10th term. That's easy. We just do a10 is equal to 12 times 10, that's 120, minus 4. And so a10 is 116. And so again, using that formula, an is equal to a1 plus n minus 1 times d, where d is the common difference and a1 is the first term, an is the nth term. You can solve several problems of an arithmetic sequence, or problems that deal with an arithmetic sequence. In the next lesson, I will be going over the formula that is used to find the sum of an arithmetic sequence. So thanks for watching.